Hey everybody, Mrs. Herman here. We are going to work together through problems in 1-7 today. So make sure you've already downloaded this lesson, and right now you're split screening this video along with your screen and Notability so you can work along with me, because you are going to be turning this in when you are done answering the questions in the Ed puzzle, as well as filling this out along with me. So, all right, let's go ahead and jump right in. We are going to cover problems 119 through 123, so quite a bit today. I'm going to hope I don't go too fast, but I also don't want to make this video too long. So our goal today is I can calculate the probability for compound events. So compound means more than one. So now we're not just talking about the probability of rolling a 6 with dice or flipping a heads. We're talking about what's the probability of this or this happening. Our keyword today, and this sounds super simple, is going to be or. We're not doing compound events yet with the word and, because that is something different. Or means this could happen or this could happen. How do I find the probability that either of those things could happen? We're going to solve that today. So if we jump right into problem 119, make this just a little bit bigger. Okay. Thomas helps around the house by doing one chore after school. Each day, Thomas and his aunt use the spinner at the right to decide which chore he will do. Here's what Thomas knows. The sections on the spinner for rake leaves and do laundry are the same size. So this and this. These two are equal to each other. The sections for clean bathroom and vacuum are equal in size, and together they make up half the spinner. So we know that if this is 1/4, that this also has to be 1/4 to make up a half. And then it tells us about cleaning the bedroom is 1/3. So what's the probability that Thomas will spin do laundry? So we have to figure out what fraction represents that probability in that section. So if we already know most of it, let's go ahead and add up the 3 pieces that we do know. So I know 1/4 and 1/4 is already 1/2. And I'm going to add that to the clean bedroom fraction of 1/3. So, we are going to do common denominators here, which I'm going to use my least common denominator of a 6. So that's going to give me 1/2 is going to turn into 3/6, and 1/3 is going to turn into 2/6. So 5/6 represents the parts of the spinner already accounted for. So the leftover is going to be what represents raking leaves and doing laundry together. So 6/6, which is the whole spinner, minus 5/6 that's already marked down, gives me 1/6 that represents the raking leaves and the doing laundry. I just care right now about doing laundry. So I need to break 1/6 into 2 equal sections. So remember, that's the same thing as doing the reciprocal of my second fraction. And so that is telling me that the probability, make sure we're writing it this way, that he has to do laundry is going to be 1/12. Okay, so if I were to fill that in up here, kind of erase those, this is going to be 1/12, and then I already know this is the same size, so I'll go ahead and fill that out. It's going to help me later with another problem. All right. Letter B, Thomas hates to clean the bathroom. When he spins the spinner, what's the probability that he will not point to clean the bathroom? So basically, everything else but cleaning the bathroom. Okay, so if I look back up at my spinner, make sure I accidentally the first time looked at bedroom, and he doesn't want to clean the bathroom, and I don't blame him. That represents 1/4. So that's the probability that he would land on cleaning the bathroom. This is asking the probability of not cleaning the bathroom, which means I'm going to add up all those fractions that are not cleaning the bathroom and combine those together, because he wants to do anything but cleaning the bathroom. So if you add all those up, 1/12, 1/12, 1/3, 1/4, or let's kind of think logically about this. If the part he does not want to do is 1/4 of the spinner, that means the whole rest of it has to be 3/4 of the spinner. So the probability of not cleaning the bathroom, make sure to write that event in parentheses. That's super important we set it up this way, is going to be 3/4. Or maybe you want to write it as a percent. That's fine, 75%. Okay, awesome. Moving on to 120. Thomas's aunt hopes that he will either spin, clean the bedroom, or rake the leaves. I'm going to bring this down so we can still see the spinner. There we go. So it's asking, so clean the bedroom or rake the leaves. What is the probability that he's going to clean the bedroom? So the first question is just clean the bedroom. So I'm going to look up at my spinner. I see that cleaning the bedroom is 1/3. So the probability of him spinning clean the bedroom is going to be 1/3. All right, then I have to figure out the probability of raking leaves. So if I look up there, raking leaves, we figured out in the previous question that was 1/12. Okay, so there's my two separate answers for those. Now for B, it says spinning either chore in part A. So either cleaning the bedroom or raking leaves would make Thomas's aunt happy. I know it says with your study team, we're going to do this together through the video. The first question says, what's the probability that he will spin either one of those chores? So one or the other. So whenever you are finding two compound events, or a compound event meaning this or this, it doesn't matter which one you choose, okay, or which one happens. You're going to combine those fractions or those probabilities together. So in order to do that, okay, we have to figure out, we're going to combine those two things together, okay, the probability that he will spin either one of those chores. So we are going to do 1/3 plus 1/12. So my common denominator is going to be out of 12. That one will stay 1/12. This one will turn into 4/12. So the probability, okay, and this one I know it's a long thing to write, but we have to list both events, that he could either spin on cleaning the bedroom or he'd have to rake leaves, is going to be 1/12. Oh, sorry, 5/12. Okay, awesome. And then when it's saying how can you write those two outcomes as a single probability, you're just going to add the two outcomes together. So whenever if you have three events, maybe I wanted to figure out what the probability that he would spin cleaning the bedroom, raking the leaves, or vacuuming, I would go ahead and add those three fractions together. So you just combine everything together that you are possibly spinning, the events that you are wanting to happen. All right, on to 121. Okay, so different sort of situation here. We're not talking about the spinner anymore. It says Mrs. Nugent lets her students borrow pens and pencils on days when they have a quiz. She has a paper bag containing hundreds of wooden pencils, mechanical pencils, and blue pens. Stuart forgot his pencil and it's quiz day. She tells him that one out of every 3 students who reaches into the bag pulls out a wooden pencil. So I'm going to write this down. This is going to be important that we remember this information. So probability of choosing a wooden pencil, she said, is 1 out of 3. 2 out of every 5 students pull out a mechanical pencil. So the probability of pulling out a mechanical pencil is going to be 2/5. And then it says the rest of the students pull out a blue pen. If Stuart reaches into the bag without looking, is it more likely that he will choose a wooden pencil or a mechanical pencil? So we need to figure out basically which one's bigger, 1/3 or 2/5. You can do this a number of ways. I like to kind of go with my cross multiplication. It's a quick way to figure out that 2/5 is going to be bigger, okay? So it's more likely he will choose a mechanical pencil because that has a larger fraction. And so justifying our thinking would be that 2/5 is greater than 1/3. Okay, and then letter B says, how can you describe the probability that Stuart will pull out some kind of pencil, either a wooden pencil or a mechanical pencil? So we just care that it's a pencil. So wooden pencil or mechanical pencil by using the probabilities that you already know. Consider what you know about adding and subtracting fractions and see if you already have a strategy to write this probability as a single number. All right, so for these, we are going to go ahead. Does it want us to? Oh, so this one, okay, so the probability, it doesn't want us to actually solve it. We're just going to go ahead and add them together. So we're just going to take the probability of a wooden pencil and we're going to add it to the probability of a mechanical pencil. Okay, so that's kind of our justification for how we would do that. We're going to add those two fractions together. You don't have to actually solve them yet because we're going to do that moving into 122. So Felicia was trying to find the probability that she would pull either a wooden pencil or mechanical pencil. So the same problem from above. I think I need to combine the probability that I will get a wooden pencil with the probability I will get a mechanical pencil. And so she drew a picture of what that would look like. She asked if she could add the parts. Now for you guys right here, there's a fraction that got left off of the PDF. So go ahead and write 3/8. Sorry, that looks like a bad 3/8. Let's fix that. So is the sum 3/8? Why or why not? So where are they getting 3/8 from? They're getting it from a piece here, and a piece here. So there's the 3, and there's 1, 2, 3, 4, 5, 6, 7, 8. So that's where she's getting 3/8 from. So she wondered if she could just add the parts. Is the sum 3/8? Why or why not? So that's where she's getting it from. But is that correct? Can you add those together? Are they the same size? Right, you can't do it that way. We know by now that you can't just go ahead and add across. Look, if you're looking at that problem, she just added her numerators and added her denominators, okay? So we are not able to do that. So no, the parts are not the same size. We have to have equal parts when we add or subtract fractions. So I know it says discuss with your team, but we're going to solve that right now. How can Felicia change the way she writes each fraction so that she can add them easily? All right, so we're going to go ahead. If we're doing 1/3 plus 2/5, let's go ahead and come up with a common denominator. Okay, this is going to turn into 5/15. This one is going to turn into 6/15. And we're going to add those up and we're going to get 11/15. So the probability that she could pick a wooden or mechanical pencil is 11/15. Okay, awesome job. And this last problem, we're going to go through this pretty quickly. So it tells me Steve shuffles a standard deck of cards. There's 52 cards in a deck, and he's turning them over one at a time. The first 3 cards he turns over are an ace, a 4, and a jack. So you guys know with playing cards, there's 4 different suits, and it's the same cards in each of those suits. For example, there's 4 aces, there's 4 4s, there's 4 jacks, there's 4 of everything in a standard deck of playing cards. Okay, you can go to this site if you want to, but if you know enough about playing cards, you'll be able to answer these questions. So if there's 52 cards and he took 3 of them out, how many cards are going to be left in the deck? Yep, you're just going to do 52 minus 3, and that's going to give you 49 cards. Good job. How many of the remaining cards are aces? So one of those cards was an ace, and if there's 4 of every card, there's only going to be 3 aces left. Okay, what is the probability that the 4th card will be an ace? So the probability that he's going to pick an ace at that point, there's only 3 of them left, and there's not 52 cards anymore. He took 3 of them out. There's only 49, so my probability is going to be 3 over 49. So it says, last and final question, instead of getting an ace, he gets a 2 as the 4th card. The 5th card is a 5. What is the probability that the next card will be a king? So the probability that he's going to pick out a king. So ask yourself first, how many kings are left? He's not pulled any kings out, so there's still 4 kings. But he had 49 cards left, and then he just pulled out 2 more cards. So he doesn't have 49 cards left anymore. He's only got 47. So our probability that he could pull out a king would be 4 out of 47. Awesome job, everybody. Go ahead, finish up any notes you need to take on here, and then go ahead and submit to the assignment. Make sure to watch this video all the way until the end so you get credit for it, and you should be good to go.